Okay, so this is going to be a teardown and possible repair of this. It's a Tasco NV360 night vision monocular. I wouldn't say it's a cheap thing, but it's one of the lower priced end models of night vision monocular you can get. But in my opinion, it's still pretty well built. It has a really nice, durable plastic case. It feels a little chintzy to me personally, but it's a robust plastic. It says made in Ukraine, which that's pretty cool if it actually is. Seems like it has a nice aluminum lens and it has coatings on the front that filter out certain wavelengths. And there's the eyepiece on the back. So like most night vision binoculars, this uses an image intensifier tube on the inside, which is a special type of electron tube, which at one end it has a on one end of the tube it has a special coating that when light hits it, it emits electrons, and then there's a high voltage applied to the tube that accelerates those electrons towards a screen at the back, and it creates a brighter image than the one that comes in the front. And these do have a limited life, like there's different categories of the tube life, and I'm not quite sure which category this one is. But this one is non-working. You turn it on, it lights up, but there is no image coming through. And I looked at it earlier, and it looks like there's some discoloration on the front window. Let me take this lens off and show you. Okay, so looking at the front, here's the front window of the image intensifier tube, and you see that there's a line right there. It's like a little mark. I do not have very much experience with these, but I would say that's a bad sign. I think that this tube probably has air in it, or is at least past its due date. But it should still be fun to open it up and take apart. I just read on the Wikipedia page some of these use something kind of weird for the high voltage generator. It's like a piezoelectric high voltage generator. So that'd be interesting to see if one of these is inside. So I'm going to take the screws out. It looks like there's a, I don't know what you call this, but it's like it's a nut that has two notches in it, and I need to get like a pair of pliers that can fit in there so I can unscrew it. And we'll see what it looks like inside. So I've taken this front ring off, and this lens came off, and now there's this ring on the back I'm taking off. Okay, so there's a little circuit board right here. Has the switches and LEDs on it. Looks kind of rough around the edges. It doesn't look very clean cut. Doesn't look the best to me personally, but looks good on the outside. Looks like the switches have like brass nuts or something on the other side for the screws. Okay, so this is the item we're really interested in. It looks like all of the electronics for generating the high voltage are inside this little block right here, and it just has two wires going onto the board. Right here, here's the battery container, battery area. This uses like some lithium cells. And this right here is an infrared illuminator, just to give a little bit more light. Here's you can see the phosphor screen right here. I haven't ever actually seen this working, so I don't know if that would be green. I would think it would be green. And there we see the discolored window. So I'm going to poke at this for a little bit more and see if I can get this metal shield off. And then I'll come back when I'm going to try to take this silicone off, because that might be a one-way trip. I thought before I take it apart any further, I'd just do a quick idiot check. So, I have my power supply hooked up, set for 6 volts. And I'm just going to make sure that the batteries aren't a problem, even though it has new batteries in it. No, there's absolutely no light whatsoever coming out of the front, so I think we're safe to take it apart further. So there's another one of those nuts with slots in it, so I just used a needle, nose pliers, and I just undid it a little bit, and I think this is ready to come out. So there's a silicone boot on the end. You can see the discoloration right there. Here's the screen on the back. Looks like it has 2 evacuation nipples right there. Okay, so it's like a Cyrillic letters 3 and then something that looks like an N, 3 looks like a Y, 2, 9808. So that's whatever this tube is. Take this off. Okay, so right here is a copper ring. So this metallic surface is one electrode of the tube. Focus. So I'm guessing this is connected to one end of the high voltage, and then this cylinder on the back here has a feed through going through there, and that's the other terminal. And then this right here is the high voltage generator. So I'm going to cut this and then carefully try to get this off. I'm not quite sure if I can film that or not, because I think it'll take me a little bit. So this looks like it's going to come off pretty easy, so I'm just going to make a fool out of myself on camera. Spoke too soon. Okay, I'm going to hack at this for a few minutes and then I'll be right back. Okay, so I'm glad I paused because I really had to take my time with this because it was really gunked in there. So here we see the outer connection and the inner connection. See right here, there's a glass stem that goes down here and it's sealed around here. And here's the other connection. The reason I had to be so careful was because of this piece right here. I couldn't just rip it off because that would have broken this, so I had to be very careful in taking this off. I also had to dig a bit of the goop out from in the middle there so I could snip this high tension lead off. So I'm gonna clean this up a little more, get all the silicone off so we can take a better, clearer look at it. Okay, so as you can see, I've gone a little bit farther than just taking the silicone off. I've actually taken off the entire coating on the outside. This was coated on the outside with something called Aquadag. It's basically a conductive graphite paint that they paint on the side. And it's just an easy conductive paint that they use. So at the front right here we can see the photocathode. That's what this plate is. On the inside there's a clear coating that when light hits it, it emits electrons. And it's actually conductive. So this plate, it's sealed onto the end here, but the plate is actually slightly larger than the opening that it seals onto. So there's a little bit of the photocathode that's at the end right here. And that's important because we have to connect one end of the high tension supply to this. And what they do is, since this is such a large area, they just coat the entire thing in graphite connected to here and call that ground. So this, I think this is the negative, so the entire thing will be coated with graphite and that will be called ground. This thing right here, I think is actually the anode. So this is the photocathode. Light hits here, it emits electrons. So this is at a negative potential. I think this would be at a positive potential. And then the electrons will be drawn up, accelerated, and then they'll hit this screen. And wherever light hit here, there will be electrons that get drawn. And they'll hit this green in respect to where they were on here. So you remember earlier I said there was like a mark right here? You can see there's like a stain. Well, if you look right here, do you see that? There's a little crack right there. So what happens is I think that this was either handled roughly or fell, and it cracked right here. And this stain right here is actually something called the getter. It went white. So like in a normal vacuum tube, if you see something like this is a 6SN7, it has the shiny part on the top. That's called a getter. What they do is that in these there's a ring of material that they heat with an induction heater, and it sputters off, and it creates a active metallic coating that if there's any oxygen or water vapor or something in here, it will touch this metal. It'll oxidize the metal, and it will remove the contaminant from the vacuum system, or from this vacuum envelope, because these need to be under vacuum in order to work effectively. You can see it on here as well. Big shiny spot. And on a tube that is bad, you see how it's gone white in the top, because that material is trying to remove oxygen from our entire atmosphere, and it's not going to succeed, so it just all oxidizes and turns white. So in these, they use an induction heater on the outside to flash these, called a getter flasher. But on this one, they do it different. If you can see down there, it's going to be hard to see because of my crappy phone, but there's actually a tiny little filament right there. And what they do, it's like, so I think this is the anode, so what they do, this actually isn't one connection. If you see, there's two wires that are twisted together. And you see there's two seals in there. One of these seals connects to this metal can, and another, if you can see that wire running around in there, goes to one end of that filament that's coated with the special blend of metals that are able to absorb oxygen and other things very readily. So this was heated up. That sputtered metal onto the inside of this envelope. And when this crack happened, air got into the envelope. The metallic coating in here tries to keep the vacuum perfect, but it can't win against our entire atmosphere, so it just all turns white. And that's what that discoloration is. See some of the white right there. So I don't think there's any point in cracking this open because we can pretty much see everything that's happening. So I think I might keep this or might give it back to the owner that gave me this for the teardown. Okay, so what we're left with is this high voltage module. I'm not sure if I want to open this up because if I get in a working one of these image intensifier tubes in the future, this would be useful to have. So I'll think about it, and I might crack this open still. Okay, so I've taken this apart as far as I dare. I'm going to try to get some light in there. It's going to be tough. See, there's a tiny little circuit board. And there's a small transformer, which looks like it's feeding into this box, which is probably a voltage multiplier. I thought it might be one of the piezoelectric ones, but I don't know, maybe this one's just old or something like that. Unfortunately, I don't want to take it apart any further because I think if I go any further, I'm just going to break it. You can see there, a lot of the goo is gone. So I'll show you the kind of arcs it gives out. Pretty pathetic, but the main thing with this is just reliability and low power draw. Okay, so I have this running on about 6 volts. Puts out about maybe 5,000 or 6,000 volts or something. I'm not quite sure what these tubes run on. So that should be useful if I ever buy one of these tubes on eBay or something. Well, I think that's going to be pretty much it. Sorry this wasn't a repair video, but I hope that was at least a bit interesting.